Lesson 7-3, Solve Linear Systems by Elimination. So this is our third day to be working on linear systems, and we know at this point now a linear system is two or more equations that have the same variables. And the solution is the ordered pair that makes each equation true in the system. The first thing we did was to solve the system by graphing, so we visually inspected the intersection of the lines, and that was our solution. Then we solved using substitution, where we solved one equation for a variable and substituted that into the second equation. Today we're using the elimination method. So our third method for solving a linear system. Here's our example. Solve linear systems using elimination. Use addition to eliminate a variable. Here is our system. 2x plus 4y is equal to 2, and 4x minus 4y is equal to 16. What we want to do when we eliminate is to either get rid of our x variables or get rid of our y variables. When we add these two equations together, we have opposites here, so we'll end up with a 0 in place of our y. We have the equation 6x is equal to 18. So a simple equation, and we solve for x. We have x is 3. Now we know that the solution is an ordered pair, so we still have to find out what y is. This is similar to what we did with substitution in solving for the second variable. We're going to take our variable that we've solved for and substitute that into either equation. I'm going to choose equation 1, and I'll put 3 in place of x. So I have 2 times 3 plus 4y is 2. Notice we're down to one variable, and we have y is negative 1. So the solution for this system is 3, negative 1. And we can be sure by substituting these values back into the original system. So when I put it in equation 1, I have the true statement 2 is equal to 2. And it must make both equations true, so I'll put it in equation 2. And I have the true statement 16 is equal to 16. Next example. We want to solve using elimination, and this time we'll be subtracting. So looking at our system, we see both equations have a positive 7x. And if we can subtract the second equation and solve, I'm going to go backwards. If we subtract, be sure to see that we're subtracting every term. So I'm subtracting a negative 3y, which gives me a positive 8y. And I'm subtracting 34, which gives me negative 16. So be very careful when you're subtracting. Now I'll solve for y, and I have y is negative 2. The next thing is to solve for x. So I'll take my negative 2, and I can put it in either equation. I'm going to choose equation 1 again, but I could also do this in equation 2. And I will substitute negative 2 in place of y. Now I can solve for x, and I have x is equal to 4. So my solution is 4, negative 2. And I want to make sure this makes both equations true. I'm going to do a mental check this time. So I have 28 minus 10 is 18, and that checks. Then I have 28 plus 12 is 34, and that checks. So my solution is 4, negative 2. Next example. We're just told here to solve using elimination. Now, inspecting this, do you notice that we don't have our x terms lined up and our y terms lined up? So in this type of problem, we want to arrange like terms. And so simply we want to put the equations in standard form. Our first equation is in standard form already, so we're going to rewrite the second equation so that it's in standard form. Notice now we have our x's lined up, our y's lined up, and our constants. So this is very important before you add or subtract that you have your like terms lined up. So now we're going to add our equations, and we should expect the x's to drop out or be eliminated. And we have 9y is 18. We'll solve for y. Y is equal to 2. Continuing on, we have to solve for x. So we'll go into either equation. And once again, I'm choosing equation 1. And I'll put 2 in place of y. And that gives me x is equal to 3. So the solution is 3, 2. And once again, I'll do a mental check. I have 18 minus 8 is 10. That checks for equation 1. And for equation 2, 26 is equal to 18 plus 8, and that's true. So my solution is 3, 2. Now we'll do a couple of word problems. One day you are rollerblading on a trail while it is windy. You travel along the trail, turn around, and come back to your starting point. On your way out on the trail, you were rollerblading against the wind. On your return trip, which is the same distance, you're going back to where you started, you are rollerblading with the wind, so the wind is behind you and pushing you. You can only travel 3 miles an hour against the wind, which is blowing at a constant speed. You travel 8 miles an hour with the wind, so that makes sense. You're going faster when the wind is behind you. Use the models below to write and solve a system of equations to find the average speed when there is no wind and the speed of the wind. So those are the two things we're looking for: the average speed with no wind and the speed with wind. So these are the verbal models we have. When you are going against the wind, it's your speed with no wind minus the speed of the wind, so it slows you down, and that's your speed. When you're with the wind, you have your speed with no wind plus the speed of the wind, that's making you faster. All right, so look at what happens. This is going against the wind. Then you're going to turn around and go with the wind. So you go faster when the wind is with you, blowing you. All right, we have two things that we need to find: speed with no wind and speed with wind. So we'll just label them x and y. So our first equation is simply x minus y is equal to 3. And the second is x plus y is equal to 8. There's our system. And we see if we add these together, the y's eliminate. We have 2x is equal to 11, which gives us x is equal to 5.5. We need to solve for y using either equation. I'll choose the first one. X minus y is equal to 3, substituting 5.5. So I end up with y is equal to 2.5. So the speed with no wind, your speed, if you were skating in perfect circumstances, would be 5.5 miles per hour, and the wind is 2.5. Our next word problem has to do with a gas station that sells gas and has a car wash. A gas station has a car wash. If you get your gas tank filled, then you are charged a lower flat fee, X in dollars, for a car wash. Plus you're charged Y dollars per gallon for the gasoline. So right there they're telling us what X and Y will represent. One car uses 8 gallons of gasoline and pays $22.80 for the gas and car wash. And the other car uses 6 gallons of gasoline and pays $18.60 for the gas and car wash. We're asked to find the fee for the car wash and the cost of 1 gallon of regular gasoline. So we were told X represents the car wash cost and Y represents the price per gallon for the gas. So there we go, X and Y. Now it's a system, so we need two equations. Car 1 buys a car wash, gets 8 gallons of gas, and pays this much for the gas. Their total was $22.80. And here we have car 2. Gets the car wash, buys 6 gallons, this is what they pay per gallon, and total cost. So this is a problem where it would be good for us to use subtraction to eliminate. And I've put the entire second equation in parentheses to remind us we're subtracting everything. And when we do, the x's eliminate. We have 2y is equal to 420. We'll solve for y, and we'll get 210. So we know right there that the cost per gallon is $2.10. Now we're going to solve for the car wash by substituting in either equation. And I chose equation 2 this time because I have smaller values to work with. Does not matter which equation you use. So solving for x now, I get 6. So $6 for the car wash and $2.10 per gallon of gas. And I can verify this by substituting the 6 and the 210 into our system to see if it makes each equation true. Now, this is the last slide for the video, and what I'd like for you to do is pause the video and write these 3 problems down. So a little bit different today. For your form, you will be solving each of these systems and putting the solution into the homework form. So with this first one, you're going to want to add to eliminate the y's. For the second one, you'll want to subtract to eliminate the x. And the third problem will require you to rearrange and then to solve the problem. And I imagine it's going to be the 5y that you're going to eliminate. So pause or rewind the video to write these problems down. And that's it today. So solving linear systems using elimination. We've used graphing, we've used substitution, and next is elimination. Have a good day.